Good evening, and welcome to the Moreau Lake State Park Astronomy program in conjunction with Adirondack Skywatchers. Tonight, we're talking about telescopes. We'll discuss the types of telescopes, the types of mounts to hold those telescopes, and give you some recommendations on which type of telescope might be best suited to your specific needs. We hope you enjoy the program. Few of us work at our National Observatory at Kitt Peak. We don't enjoy the views available at nearly 7,000 feet in a clear, dry climate, nor do we have their dedicated professional observatories and multi-million-dollar telescopes. Instead, we view stars from our backyard, using a bit more modest telescope and, if we're lucky, a simple observatory, perhaps a garden shed with a removable roof. Just as we humans sense our local surroundings using two principal senses, sight and sound, there are two broad categories of telescopes. Radio telescopes, which receive various radio frequencies and affect our ears on the universe, and optical telescopes that work in the visual range of frequencies, our eyes on the universe. Tonight, we'll focus on visual telescopes. As astronomers, we're often asked, what telescope should I buy? And the answer is, as with so many other questions, it depends. It depends on what do you wish to view? Are you going to be doing astrophotography? In essence, are you going to connect a camera to your telescope? Will your telescope be in a fixed position, or do you want to take it with you to other locations? And, as in almost any buy decision, what is your budget? So, let's start with what you wish to view. We often classify targets as solar system or near-sky targets, such as the sun, the planets, their moons, including our own, comets and asteroids, and man-made satellites, versus deep sky objects such as star clusters, nebulae, and galaxies. There are two main classes of optical telescopes, refractors and reflectors. In a refractor telescope, light typically passes through 2 or 3 glass elements at the front of the telescope and is then focused by an eyepiece as it exits at the rear of the telescope. Refractors tend to provide excellent detail, can be used at high magnification while still providing a solid image, and hold their focus well since the front elements are fixed. However, the cost of manufacturing the complex front lens elements limits the usable objective to less than 6 inches, usually in the 3 to 4 inch range for home telescopes. So refractors are ideal for brighter objects containing fine detail, such as typical of near-sky viewing. It's likely that you have a refractor telescope, well, actually 2 such telescopes in your home today. Do you have a pair of binoculars? They are simply refractor telescopes that are joined together and are a simple, inexpensive way to test the waters of astronomy. With them, the sun, with proper solar filters installed, the moon, and larger, brighter, deep sky objects such as some galaxies and star clusters are easily viewable. If the sun is going to be your primary target, a dedicated solar refractor telescope is your best bet. It limits the wavelength of light it allows to pass through to the most common solar wavelengths, thus providing amazing surface detail, including solar flares and sunspots. Most professional telescopes, such as those found at Kitt Peak or the Hubble Space Telescope, are reflecting telescopes that use 2 or more mirrors to focus the image. Light enters through the front of the telescope, is reflected off a primary mirror at the rear of the telescope, and is then reflected off yet another mirror mounted near the front of the telescope, either back through an eyepiece at the rear of the scope or through an eyepiece mounted off the side of the telescope near its front. Reflectors offer excellent color correction and can be purchased with larger objectives, typically in the 8 to 20 inch range, and are thus better suited to dimmer objects such as typically found in deep sky objects. However, they do need to be periodically adjusted, what we call collimated, to ensure sharp focus. We have mentioned the term objective twice. Objective can be loosely defined as the diameter of the opening in a telescope through which light enters. The larger the opening, the more light is gathered, and the brighter the resulting image. The human pupil is about 0.3 inches in diameter. A 4-inch refractor would collect around 180 times the light of your unaided eye, while an 8-inch reflector would collect around 700 times that of your eye. This is why astronomers call telescopes light buckets and seek ever larger objectives. The larger the objective, the more dim the objects that can be seen. Now that we've covered the typical types of telescopes, we need to turn our attention to their mount. When we talk about mounts, we are really talking about two components. The first is either a tripod, for those of you that will be taking your telescope in and out at the end of your viewing session, or take it on the road to different locations, or a permanently mounted pier for those of you that will have a fixed observatory or a fixed location in your yard from which you'll always be doing your viewing. Both tripod and pier are used to raise the telescope to a suitable viewing height. The second component of the mount is the mount itself. If you watch the sky, you will notice the stars, including our sun, cross the sky from east to west. This is due to the rotation of the Earth along its north-south axis. In addition, the moon has its own unique movement, since it is in orbit around our planet. In the northern hemisphere, the North Star appears stationary, since the Earth's north pole points very close to its position. The farther south you point your telescope, the faster the stars seem to move across the sky. Mounts connect your telescope tube to either the pier or tripod. They allow your telescope tube to swing. By that we mean move up and down, left and right, or in an arc across the sky in order to follow your viewing target, independent of the tripod or pier. Mounts can be manual or electric. For infrequent users seeking to minimize cost, who are likely to only view objects for a few seconds or minutes, and who are intimately familiar with the sky and its objects, so they have no problems finding and centering them in their telescope, a manual mount is sufficient. However, if you have difficulty finding your intended target in the scope because you are less familiar with its location in the sky, or should you wish to do longer-term viewing or undertake astrophotography, an electric mount is best. Electric mounts contain electric motors and gears and/or belts that will move the telescope tube to keep it pointed at your target. Advanced electric mounts, called go-to mounts, have a small computer and compass included that aids in setting up your telescope, aligning your telescope with true north, and will automatically point your telescope at any object you select from a large database of celestial objects, and then follow that object as it moves across the sky. All you need to input using a small handheld keypad, a laptop, or an iPhone or iPad is your exact location and time of day. From these two pieces of information and the internal compass reading, the computer can now determine where true north is, in effect the North Star, where any other object in its database would be in relation to that point, and its path across the sky. It can even recommend interesting objects that would be in your sky on any specific date and time. Electric mounts can be powered by house current or with a car battery or battery pack in the field, and come in two basic configurations: alt-azimuth and equatorial. Alt-azimuth mounts are the simpler of the two. They contain two simple drives, one for altitude, up and down motion, and one for azimuth, or side-to-side motion. The mount is leveled and pointed north. It then uses these two sets of drives to move up and down and to the left or right to track celestial motion. They move the telescope in a set of small steps, in effect, up 2 steps and 1 step to the left, and then up another 2 steps, and then up another step and another step to the left, to track the arc an object makes across the sky. Because of the step-like, somewhat jerky motion, these types of mounts are less well suited to long exposure astrophotography. This is where an equatorial or German equatorial mount shines. These types of mounts have one of their drive axes aligned with true north. Therefore, except for very small, infrequent corrections, they're only relying on one drive to track objects across the sky, thereby providing very smooth tracking. So, in summary, if you're looking to buy your first telescope, if it will be used only for solar observing, buy a dedicated solar refractor. If you'll be doing primarily planetary, lunar, and solar observing, or regularly traveling with your telescope, consider a 3 to 4 inch refractor. If you'll be doing deep sky nebula, galaxy, and cluster viewing, then consider an 8 to 10 inch reflector, or even larger. The larger the better. This can be considered the jack of all trades, since it will also work well for planetary viewing. Reflectors come in various configurations, with short tube catadioptic configurations the most common due to their compact size. There are also long tube Newtonians you may wish to consider if size is not a determining factor, and for the very well-heeled who wish very detailed edge-to-edge sharpness for astrophotography, there are also Ritchie-Curtius reflectors, the same configuration as the Hubble Space Telescope. But these are best left to those who are willing to invest in an observatory and heavy-duty mount. In terms of a mount, buy a computerized electric go-to alt-azimuth mount if you are not planning on long exposure astrophotography, and if cost and portability are your main deciding factors. Otherwise, go with the German equatorial mount. Buy a good heavy tripod unless you're going to permanently mount your telescope in an observatory, in which case use a concrete and steel pier. You will also want a finder scope or laser pointer to help point your telescope at your viewing target, since the field of view in a telescope is very small, making it difficult to locate your target in your eyepiece. A finder scope is a small telescope of low power that mounts to the tube of your main telescope, providing a much wider field of view to simplify locating your target object. Also plan on buying several good eyepieces. They come in 2 main diameters, 1 1/4 inch and 2 inches, depending upon your telescope focuser. You may also want to pick up a Barlow lens. This sits in front of your eyepiece and increases the magnification. We hope you've enjoyed this overview of telescopes and mounts, and that you'll join our staff and astronomers as they demonstrate their telescopes and mounts. We'll be showing other presentations that cover an overview of our universe and an introduction to astrophotography. We hope you'll come back soon to Moreau Lake State Park to learn more about astronomy. And until then, clear skies to all.